Hello everyone, welcome back to the Map of Mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of n plus 2 to the power of n equals to 35, and we will solve this problem for the values of n. And here you remember one thing is that our n must be belongs to an integer or belongs to z. So the very first thing we are going to do is here first we multiply and divide the exponent of both of the terms by 3, and we will obtain 3 to the power of n and its whole power 3 over 3 plus 2 to the power of n and its whole power 3 over 3 equals to 35. And in the next step we will use here the nice exponential law, and according to this law we will multiply the exponent 1 over 3 by n, and we will get its output in this form: 3 to the power of n over 3 and its whole cubed plus 2 to the power of n over 3 and its whole cubed equals to 35. So now in the next step we will convert this nice exponential equation into the cubic form, so that here we will just take only a equals to 3 to the power of n over 3, and we take b equals to 2 to the power of n over 3. So here we just substitute this value and this value in a and b, and here you remember one thing is that our ab is belongs to positive integer, and this a and b is not equals to 1. So now we can solve this problem by remembering these conditions. So in the next step we will write here these values in this equation. So our this equation will becomes in the form of a cubed plus b cubed equals to 35. We will just substitute these two values in this equation, and we will obtain here this nice cubic equation. So now we will open this cubic formula, and you will get its output in this form: a plus b times of a squared minus ab plus b squared equals to 35. And now you focus in the left hand side, and in the left hand side we have two factors which is multiplied by each other, and now we need to make the two factors in the right hand side. So you focus in the right hand side, and we have the factors of 35 are 1 times of 35 is 35, and 35 times of 1 is 35, and 5 times of 7 is 35, and 7 times of 5 is 35. So now you focus on the left hand side, and you see that we have a plus b. A plus b is less than a squared minus ab plus b squared. So if you make the relation of a plus b and a square minus ab plus b square, then you will obtain this one. So now you just make the relation of all these two pairs, and you just equate those pair in which satisfy this relation. So if you compare 1 and 35, and you see that 1 is less than 35, and similarly if we write this one, and here you see that 35 is greater than 1. So this term, the first factor is less than second. Similarly here the first factor is less than second, so it is okay, and it is not relevant to this one, so that we will reject it this one. And if you focus here, then you see that 5 is less than 7, so we will use this. And here you see that 7 is greater than 5, so that we will reject it. So here we accept these two pairs, 1 times of 35 and 5 times of 7. And now we compare these two factors by this factor. So here we have two cases. The first case is we will write here So when you compare the first case, so you will get or you compare this case by this case. So here you have a plus b equals to 1, and our other factor is a squared minus ab plus b squared equals to 35. So here we have, this is the case number 1 and this is the case number 2. So now first I can solve our case number 1. So in this case, we will first take the square on equation number 1 on both of the sides, and you see here I can name this as equation number 1, and we take the square on this term, and you obtained here a squared plus 2 times of ab plus b squared equals to 1. You know that the square of 1 is 1, so I will name this as equation number 2. And now we subtract these two equations, and here you see that we will just change the sign, and these are gone, similarly these are gone, and here you have minus 3 times of ab equals to 34. And now you will obtain the value of ab equals to minus 34 over 3. So here you remember one thing is that here we just write our a and b must be positive integer, and it is the product is not equal to 1, so that here you see our product of ab is not an integer, it is minus 34 over 3. It is not an integer, so that we will rejected this case, so it is not possible, so that we will just rejected our first case, and now we can just proceed here our second case only. So our second case should be, we just equate a plus b by 5 and 7. So you get here a plus b equals to 5, and our other case is a squared minus ab plus b squared equals to 7. So now we can just proceed here the second case. So in this case we will easily solve, and we get the values of a and b. So that now first I can find the value of a from this one, and here you see that we have a equals to 5 minus b, and I can name this as equation number 3. And now we put the value of a here, then you obtain 5 minus b squared minus 5 minus b times of b plus b squared equals to 7. So now we will open this square, and we obtain here 25 plus b squared minus 10b, and we multiply this b on both of the terms, and we obtain minus 5b plus b squared plus b squared equals to 7. So now we can just rearrange the terms, and we add or subtract the like terms, and we get b squared plus b squared plus b squared equals to 3 times of b squared minus 10b minus 5b equals to minus 15b, and 25 minus 7 equals to plus 18, and this whole equals to 0. So now you see here we have 3b the common term, so that we will divide each of the side by 3, and we get its output in this form. So here you have this 3 is gone, and you get b squared minus 5 times of b plus 6 equals to 0. Here you have 3 6 is 18, and 3 5 is 15. So now we will make the factors of this quadratic equation, so that the factors of this equation are b squared minus 3b minus 2b plus 6 equals to 0, and here we take common b, and we get b minus 3, and we take common minus 2, and we get b minus 3 equals to 0. So here we have these two factors, b minus 3 equals to 0 and b minus 2 equals to 0. So we get our first factor is b equals to 3, and the second factor is b equals to 2. And now we back substitute the value of b in equation number 3. So equation number 3 implies that our equation number 3 should be a equals to 5 minus b, and now we put the value of b here, and you get, when you put b equals to 3 here, then you get a equals to 2, and when you get put b equals to 2 here, then you get a equals to 3. So we make the two pairs. The first is a equals to 2 and b equals to 3, and the second is a equals to 3 and b equals to 2. So now here you see that we will just take a equals to 3 to the power of n over 3 and b equals 2 to the power. So we need those factor in which the base of a is 3 and the base of b is 2. I will choose just these two factors here, because the value of a equals to 3 times of n to the power of 3, so we can reject it this case, because it cannot gives us the integer solution, and we will just proceed here this case only. So in this case we have a equals to 3 and b equals to 2. So we back substitute the values of a and b here. So we know that a equals to 3 to the power of n over 3 equals to 3, and the value of b equals to 2 to the power of n over 3 equals to 2. So now we equate both of the sides, and we will get n over 3 equals to 1. Similarly here you equate and you get n over 3 equals to 1, and comparing both of the cases you will get the value of n equals to 3. And this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.